Well, the sun's out. I still haven't received those specialist bulbs, but I think you can see from the little picture that the light is now on. And I'm sure you've all been waiting to find out where the rocking horse comes into it. And just as an incidental, I never did have a big pedal car, but my dad, being ever the practical man, he made a red sit-on train I could have. It's a wonder I actually survived to make this video, because where we used to live on Barry Island had a lot of big steps down the house, and apparently I rode the train out of the back door and straight down those steps. And luckily the train and I seem to be made of fairly robust material, because we both came out with just a few scratches. So let's pick up where we left off and look at some of the clever things in that Logic Cosmos Electronics kit. Hope you're enjoying it. Now here's my bag of replacement bits I've made up. So I've got all the same resistors as are in the set, and I've made some new couple of transistors, different type. The other option, I think, BC538s. So, and I've made up a couple of, I've used some multicolours because it's a bit more fun. I've only stripped some of the blue ones. So we've got some of the leads that are needed, and hopefully the short and the long lengths. Yep, there's a shortish one. So just wanted to show you one of the cool tricks in the manual is the this red thing. You've got a little marker by here and on the edge of it. So you put that over the corner of the red one, like that, and it allows you to bend the leads so they are the exact right distance to go. And you can use the longer ones as well. You can stick them on the other two parts of the stick it on the bottom of the desk, stick them on, get them centered, and then just bend it down. Look at that, isn't that great? So we can easily make the little jumpers that are needed for doing the jobs. Put that back in the box so we don't need it. A lot of the circuits in this use both breadboards, but you don't really need them both. So if we skip over the battery thing and lighten the bulb, the little red tool also acts to be able to get the batteries out if the battery compartment if you need. It's a very multi-purpose tool. All the tools do lots of different things. As I say, we've got the fitness switch, which has already been done, and we've got a thing about joining the two connectors together, which I don't strictly need to do because we've got a bulb on the board. It's a multi-bulb problem. Switches, and here's another little cool tool. The multi-tool can be used for there's another way of quickly bending these small connectors as well. And obviously if you've got a resistor, one of the resistors which are actually new old stock, which is why they look like they should be part of the kit, and you can put that in there, measure that one like that, fits there, centered, lead goes down, and you've got a nicely bent resistor ready to go in the board. So that tool actually comes in quite handy in a later experiment as well. I think a little way up the book you'll find that when they introduce the capacitors and the other bits, somewhere the tool gets used. There we go. The tool gets used with a bit of paper around it, and some of that coil to make an electromagnet. So not a lot goes to waste. Very, very clever use of the parts in the kit. If we were going to make one of the transistor component ones, let's turn it on and off. It's my classic explanation of how a transistor works, and they're going to use the potentiometer on this one in order to do a brightness of the bulb. Well, it's not going to really help because the bulb's too dim for us, but when we get the real bulbs, we'll redo that one, I think, so we can make a bulb dimmer circuit. But we would have to put the transistor in the connector here, and in order to do the transistors, it's got quite a bit about them. So for our transistors, which are the BC238Cs, so the 238C is collector base emitter, they're going out that way, and this is where the little red tool comes into play, because down here on the bottom of it you actually use the tool for splaying the transistors tool. So the end of the tool has got a little flat in it where the transistor goes, and that allows you to actually bend the transistor's legs out so that the base collector and emitter are in the right places. That goes out that way, and that comes down over the hoop. I've just snapped the leg off the transistor, I think. I'll leave that in the outtake, shall we? Okay, so you first of all do it that way, and then you've got to turn it upside down so it goes the other way, which then allows it to sit in the thing so that you can bend the wire that way without snapping it off, and that way, and that way. There we go then. So now hopefully I won't snap the legs on this transistor. There we go. Nice and neat, and that should fit when we put it into the particular part of the yellow connector. Should just fit in there like that. There we go, look at that. Absolutely spot on. Lovely. So I expect I can probably solder the wire on that other one. Oops. Well, looking at that one, I think maybe the other transistor in the kit didn't actually have its leg rotted. It was a bending mistake by the original kit owner as well. So not being careful enough, too ham-fisted I was. You see then these little short ones will loop from one connector to another, and the resistors will be able to go from one and jump all the way over to multiple connectors like that, as will the longer wires. So they just pull in and clip. So it's nice and easy to make some connections back and forth to the various devices. So I think obviously as well in the kit was this envelope from the original owner in Nottingham with the number 3782 on the envelope packet. So that is actually, for those who are curious, a set of foolscap papers with a Leeway Logic Science Club. So, dear member, June 1976. So, from Hugo Leyden. And of course, we can take a little look at this now with several pages of coverage on the Science Club. We can see from that newsletter, or the letter, that this is the link to Leeway. And in fact, if you look at the bottom of the letter, they were interested in trouble getting certificates over from Canada, so they were obviously importing them, but they decided to send out this first newsletter, and it's Leeway Logics, Patterson Edwards, and that's the link, of course, to the pedal car we looked at earlier. And you know, it's basically Leeway Toys. They were a toy manufacturer, Patterson Edwards, South East London company in 1892, by Harry Stanley Jarvis, based in Peckham, I think. So in the 1920s they moved into a place called Hurst Lodge in Lee and built a factory to manufacture rocking horses in the grounds of that area. And they soon branched out to make the prams, toy motor cars, toy bicycles and tricycles that we saw in these sites. So they reckon it was the Leeway trademark was registered in 1955. Sadly, the newspaper report in 1966 is referred to on one of these pages that says, "Once more the horse has been overtaken by the car, and this will be the last Christmas for Leeway's hand-carved rocking horses, which have been made for 75 years by Patterson Edwards in Lee Green, as the apprentice who took over from 65-year-old Mr. George Brown in June left a few weeks ago, and there's no one to replace him." So Patterson Edwards moved to Orpington in 1970, so that would have been when this letter was sent out, and we've obviously got the rest of the newsletter that went with it. was the first newsletter from the thing covering electronics, and this is in this period in the 70s, obviously. So sadly, the company were wound up in 1981. So the year we set up Gilsoft. So change happens. But it's an interesting couple of pages on topics around what transistors are. Wonder of Flight, because of course, as we'll see in a minute, they did some other types of kits as well, and a project for osmosis. Maybe we'll need to take that a good try of that one, and a puzzle quiz to send your answers in. Unfortunately, we haven't got issue 2 to see what the answers are, so we'll have to take a little look at those at a later date. This parts order form in detail. The actual address is the leeway one for the components, and the price has got a little pound sign hand drawn in, so I assume that means the Canadian conversion was exactly equal cents to, and you had a 20p handling fee. The last page of the newsletter is a sort of list of the different kits they've got. So the 10-in-1 electronics, a small kit, motor generator, that looks quite good to build actually. Astronomy with a build your own telescope. It's got a star map in it as well. Electronics, the 7100 kit, I think that's the one I had that had just the red one, the red board, and they got an aeronautics kit. The electrics one, which contains the motor and a few others. A lot of the kits were variations on a theme. The super electronics kit, the one we're looking at the moment. One on optics with a camera. There's some links below to the sort of some Flickr sites. We've got pictures of these goods in them. And the electronic computer. Now, it's not quite what you might think, and something we may take a look at perhaps at some point. It's a bit of an unusual machine. It's there's no actual electronics in it. If you're interested to see a similar one, Fran Lab did a teardown of the Tandy kit, which is actually just a variation of it and the same experiment and very similar. So she bought it in a thrift store. So that's worth watching, definitely, if you're interested in seeing it put together. So there are a few sites as well that have got them. Where one of the ones, WorthPoint, they've highlighted one that isn't in that list, which is the radio technology, and has a 6 transistor radio set in it. If you look at it though, it's very similar with the yellow and the red kits. It's obviously got a loudspeaker in it, so we've got an extra amplifier stage, I think, with the 6 transistors. They've got links and pictures to quite a lot of the kits if you're looking for them. So the optics and the telescope one, and the motor generator thing. So quite a good site if you want to have a little scan around things. If you sign up and subscribe, you can see the value and how much they sold for as well. So that was the various kits from Logix Cosmos. Put that back in that envelope for safety, I think. There we go. And put the book back in its place here in that lovely kit. And we can then put the box back on and cover. And when we get the right bulbs, we'll give it a little bit of a go. And we can take a bit more of a look at this cracking kit. So I have the ones that I bought to repair the Logix Cosmos computer set. So you probably try one of these. This is the ones I was thinking of using. These are the 6 volt. I think they're 60 milliamp. So we stick one of those in at 4.5 volts. It should still light. It does, and barely, well, 0.08 amps, so 80 milliamps. So that's pretty good. That's not far off the 70 that we did. Probably well within the ability of the transistor to switch, and bright enough to be able to see it, I think. So we could use one of those. I was right, a 6 volt one would do it. So maybe we can do the transistor experiment then. So onwards with the video. So we can put this bulb in, and it should be able to just run as was. So just check it all connects in the circuit, if you will. There you go. So we can light it fine. So this is back then to the dimming one, perhaps, maybe. So the circuit that was dimming, which allows us to look at the dimmer circuit. Is that the one? Definitely. I think it's this one here, yes. So it's the circuit shown there, which is fairly straightforward. So basically the potentiometer controls the, there's a fixed resistor to the base of the transistor, and the transistor directly controls the flow of current through the bulb when it turns on and off. And how far it turns on and off is controlled by the variable of the potentiometer. And of course there's a battery and a switch involved, so you can turn it on and off. It's the, in fact, it's the one just below my favourite diagram. In case I hadn't mentioned it, I like those diagrams. So we've got the one of the transistors was already bent and ready to go, which I'll have to find again because I've taken it out. There we go. So that can go in there. Make sure I get the base the right way around, yeah. Okay, I found the bag of components. There we are. So we got the replacement loops and the various components in the bags, so they're ready to go. So we'll look at what else we've got to do. We need a few different bits. We need the potentiometer to go into the set as well. So I'll orient it the same way as they've got, which is the right way up actually. I've had it upside down for a while. So they put the potentiometer in this one. Like that. And then we need some loops of wire to turn the switches and connectors on and off. I left my shunt resistor in that pack. I can go out in the other bits now, we don't need it. Should of course find some shorty ones, which I have. So. Make sure it bites. Yep, it does. And then we've got a ready bent long one from the other day, which takes this up to there. Okay, and then that's got a 8.2 K resistor. Of course, handy colour code printed on the back of the magazine, so we know the 8.2 K should be green, red, red. I probably didn't have an 8.2K, did I? 680, some of them still got. We could of course use the original 8.2K from the circuit set, perhaps. Yeah, go on then. Being as though we got it, I think it wasn't too far off of the range. What was the 8.2K? It was 9.6K, which would be more than enough. So. That goes on there to there. Use the original components. So now, if you look at the circuit, the switch should start here. It's off at the moment, so it should be safe enough. And the switch then controls the negative rail for the potentiometer and for the emitter of the transistor, which is correct. And the potentiometer, the one side of it goes to the resistor into the base, and the other side goes straight up to the positive rail. And the bulb is between the positive rail and the collector of the transistor, which is correct. So that is that circuit built on that board. So now, in theory, if I turn that potentiometer all the way down and turn it on, we should get a very dim bulb, or nothing at all perhaps. till I turn it up. There we go. So as we turn the potentiometer up, the bulb starts to light at about, it's drawing barely for, you can just see a glow actually. You probably can't see it in the camera, but I can just see a glow now at about 40 milliamps. So we start to turn the potentiometer up and it climbs all the way up as the transistor is used to control the current flowing in it up to about, there we are, there's the 70 milliamps, which is about the maximum that the, there we are, we just starting to touch the 80 milliamps, so there you go, so at 4.5 volts, so it works fine. That's the circuit from the super electronics working to control the bulb brightness with the potentiometer. Isn't that great fun? I fixed the leg on that transistor, so just to prove it's operational, the bulb does go on and off and come up and down with the circuit. So I soldered the leg on the other transistor, so we now got two. Obviously there's ones in the kit as well. So this is just a tester. This is the actual 8K resistor, rather than reusing the 8.2 from the kit. It was buried in, I couldn't find it. Is this an 8K, not an 8.2K? So it's close enough. So the whole system obviously transforms quite quickly into any circuit you like. So there's quite a good one here, which is add-in sound, and is based on an earlier one, which is the police car flasher, which is a bistable multi-vibrator. So maybe we'll just transform the kit into the into that and see what happens. You won't be able to hear the earpiece, but maybe we use a bit of modern engineering to try that. So let's see the kit transform into another circuit. Well, I mean, the flasher circuit is actually working, because I didn't build that first. So it goes all the way from on completely. This is a multi-vibrator. Obviously at lower cycles the bulb's not quite so bright, but it does. I haven't tried the audio out on the circuit yet. We'll try it with a little earpiece maybe. Let's see if there's anything on the audio. I don't even know whether the earpiece works. No, nothing on the audio. Why is that? Is that because it's not making good contact maybe? Let's get a speaker and hook it up, shall we? And see if we get any audio. Okay, so we'll have a speaker to try instead of the microphone. Let's first of all do some basic continuity tests to make sure that the thing is actually... let's power it off a minute. We just check that these contacts are actually connected. Nope. Ooh. Poor connection. Right, so it does make a connection, but very poorly. So maybe that was the problem all along. Let's give you a chance to hear it as well, shall we? We use a modern amplifier, of course. There we go. It works. Just have to see if that earphone's working as well. That should have been listening to the clicks. No. Looks like the earphone's actually dead. So it's not the end of the world though. It's only for looks. But worth remembering if we're building radio circuits. But it does work if we put in the speaker. Oops. I took some liberties with the routing of the jumpers, just because we haven't got any batteries. I eliminated the routes to the battery, and went pretty much from the circuit diagram as I probably would have done today. But there we go then. transformation to a slightly bigger circuit. Obviously that kit got my interest in electronics going, but it wasn't long after I had it that we started using these, which are the micro deck. You'll see these advertised in electronics magazines. So they were clipped together, so very early breadboard, I suppose. So you could actually, they do come into 2 pieces. There you go. It's clipped together with this clever thing for putting potentiometers on the front, and this one has actually got a couple of adapters that allow you to plug in ICs as well. So electronics became a pretty important part of my life then, and a lot of bits were built on those breadboards, which interestingly we could probably build some of those circuits and the super electronics on if we wanted to easily. And of course you've all seen modern breadboards that have a lot more pins and can take big ICs, which we all use today. We had a few magazines. I mean, this predates my birth by 5 years. That's one of my dad's wireless magazines. I think the front looks remarkably like the picture of the devices he was building, but you know, this reality is there was no electronics. It was radio. I mean, this is what it was full of, you know, valve engineering and amplifiers and these sort of things. But that was the technology was radio construction for the beginner. Here's a great one. That's actually it's built on a breadboard. It really is a bit of board with the pins screwing it down. So exactly how kits were made. Well, you didn't get kits, you bought the components and stuck them down yourself. So literally the name breadboard came from that. So wonderful magazines to look back through and give you a typical time. So obviously we know I've just kept a couple of the electronics magazines from back in the day. So got this one now as well. So Practical Wireless from April 1977. So this would have been shortly after I was getting into the super electronics kits, I suppose. Gas and tug of war game, dual power supply. Again, still Practical Wireless, obviously. The wireless here from 1978. It's gone a bit bigger again now. So this was, like I say, probably hanging around our house a lot. So, homemade PCBs by now, I suspect. We were probably making our own PCBs. They're giving you the layouts, doing the action in the house. So that's easy enough to do, and obviously quite a bit with the introductions to logic circuits. So starting to understand how the logic chips running them. Here we are. It's excellent microdeck technology. It's exactly why I bought those microdecks, I expect, because I was following this set of engineering, very similar set of kit with a little radio, mains cable detector, excellent, with an earpiece to detect it. So might be a little, it's just a little project to build on a microdeck. It only needs a BC107 and has it got anything else? A 741 op amp? Absolutely. There we go. So what else have we got then? Coming up to 1978 now, we've got Everyday Electronics. This one I've I tell you what we did miss. The Impractical. There we are. So the Sinclair Radionics television. There we go then. They must be advertising in here. They did the risk calculator before that. So, the Sinclair risk calculator. I think it was 77, so I've probably been drooling over one of those. So here we got Everyday Electronics, 1978. So this one's quite important, I think, because it would have had a few things in that we were doing by then. Now these Mollard amplifiers, this is the ones I bought to build my amplifier kit. I think it was on a special offer actually from a magazine. Might even been this special offer, $12.85 perhaps. So a complete stereo kit built. So we got a vehicle mobiliser, fuzz box. Now that's probably the design I may have used to build the one I was commissioned in school. I got this copy of the magazine kits. I think we've probably got an early oscilloscope. I wonder whether that's gone to the skip now, unfortunately. We need to have a little poke around in the shed and see. And of course we got the classic Chromachime 24 or TMS 1000. I built loads of those from kits for Dad. There we go. Right, so moving on then, so 1981 we've got Electronics Today International. Obviously using it now, I'm really into computing by now, so all sorts of things, the robotics getting me interested in building electronics kits. So I kept going for a long time, obviously using their electronic circuit design reprint to learn electronics, and I subscribed to my own magazine, Hobby Electronics. I never did build the Hebot, but it's a ZX controlled one. And we still had odd magazines because Everyday Practical Electronics was a sort of combination of them up until the 1998. I'm not sure why I probably bought that one. Oh, probably because of the PIC programming maybe. I don't know, but there we go. Always been an aspect of engineering. Oh, sorry, didn't mean to leave it. I just went off to make a sandwich. Ah! And the film still was filming.